You're here because you want to master fuels and crude oil with a University of Cambridge graduate. Hi, I'm Brendan, and I'm a University of Cambridge graduate who has been teaching chemistry to many students like you over the past 9 years. I'm also the founder of the Chemistry Institution, where we have helped many students improve in a short amount of time and achieve the grades of their dreams. Be sure to check out our website in the link in the description below so that you can download a free copy of the notes for yourself and use it to run through this lecture with me today. Natural gas is a colorless gas found near the fossil fuels in the Earth's crust. Petroleum or crude oil is a mixture of hydrocarbons, which are organic compounds that contain only hydrogen and carbon. These can be separated into individual components via this separation technique that you have learned before, which is called fractional distillation. Petroleum/crude oil is heated in a furnace in the absence of air and passed into a fractionating column. Afterwards, your rising vapors will move through the holes in the trays and condense at the cooler sections higher in the column. Your hotter vapor are the ones that rise higher up from the heater and re-vaporize at the same time the condensed vapor. And after some time, the compounds with a lower boiling point, which is the shorter carbon chains and with a lower MR, will reach the top of the tower, and those with a higher boiling point, which is the longer carbon chains with a higher MR, will be collected near the bottom of the tower. Here is an example of a diagram of your fractionating column that is used in your fractional distillation for your petroleum/crude oil. Your heated crude oil is coming in from the bottom and it's going to be the hottest. Here, this is where your highest or the longest carbon chain organic compounds or hydrocarbons are going to end up because they have the largest boiling point or the highest boiling point is melting point. And here we can find bitumen all the way at the bottom. These are usually used for making road surfaces and roofing. Next up is lubricating oil, where you have C20 to C35 long carbon chains, around the 300 degrees Celsius to 350 degrees Celsius. This is mainly used for lubricating machines and making waxes and polishes. Afterwards is diesel. This is C15 to C25. This is around 220 degrees to 250 degrees Celsius. And these are mainly used for fuels for diesel engines like buses, lorry, and trains. Paraffin and kerosene, C9 to C16. These are around 150 degrees Celsius to 240 degrees Celsius. And these are mainly used for aircraft engines, for fuels. Then you have naphtha. This is C7 to C14. This is around 90 degrees to 150 degrees Celsius. These are typically used as feedstock for making your petrochemicals like plastics and your detergents. Higher up is your petrol. This is around C5 to C10, carbons long, around 40 degrees Celsius to 75 degrees Celsius. They are usually used for fuels for your motor cars. Then you have your petroleum gases, which is C1 to C4. These are around less than 40 degrees Celsius in boiling point, and these are used for cooking and heating. As you can see, the smaller the molecules, they have a lower boiling point, and they are smaller, and they come in lighter fractions. Whereas the larger molecules are all the way at the bottom. They have higher boiling point because they have larger hydrocarbons. A way to memorize this, which you indeed do have to memorize this, is to use the following acronym, or the following phrase: Peter Pan, naughty kid, don't like books. That is how you memorize the components of your fractional distillation for your field. Please memorize this. You also need to know about the limitations of using natural gases, which is these natural gases and the crude oil are all non-renewable sources of energy. They are limited natural resources. The more you use, they will eventually run out. Instead, we want to look at alternative sources of fuels, such as biofuels. These are more renewable alternatives that, compared to natural gases and crude oil, are more sustainable. An example is bioethanol from your sugarcane. These are renewable as you can just grow the plants and use them as a source of energy. Another benefit of biofuel is, compared to fossil fuels, biofuels are generally more environmentally sustainable with respect to carbon dioxide emissions. It can actually help out in the carbon cycle. Because while both fossil fuels and biofuels release CO2 during combustion, biofuels offset this part because you had to grow the plants in the first place. Growing the plants means the plants beforehand, before they were used as fuels, they had to absorb CO2 to grow and do photosynthesis. And this creates a much more balanced and renewable carbon cycle compared to using fossil fuels, which just release carbon that has been stored underground for millions and millions of years. That's all for today's video. If you really learned something and you like this video, be sure to click on that like and that subscribe button so you don't miss out on free content like this. If you want to join my community of students at the Cambridge Institution, be sure to check out our link in the description below so that you can sign up for a free trial class today. Here you can learn the exact systems that we use at the Cambridge Institution to help our students improve in a short span of time and also achieve their grades of their dreams in the end.